All right, so this is the Unit 1A test review. We're just looking at, for the first four, naming them and writing the parent function, the equation for it. First one's U-shaped. That's a quadratic. The equation is y equals x squared. The second one, we're looking at the shape. That's tall, slide looking through the point 1, 1, 0, 0, and -1, -1. That is a cubic function. And the equation is y equals x to the third power. The next one has the key coordinates, 1, 1, -1, -1. Has these asymptotes that run right down the y-axis and the x-axis. But another key way to be able to tell what this is there's two different parts to this graph. Part up here in the first quadrant and in the third quadrant. This is called a rational function. That's y equals 1 divided by x is your equation for that. The next one kind of looks like part of a rational function, but there's no part of a rational function in Algebra 2. It either is or it isn't. This is not a rational function. It is an exponential function. It goes through the point 0, 1. And there's an actual asymptote that runs right along the x-axis. So that's why this top part of the graph just kind of floats right above the x-axis. It's getting closer and closer as it approaches it, but it'll never actually get there. As it goes off to the right, it'll keep climbing higher and higher to infinity. Anyways, this is an exponential function. And the equation is y equals, I've introduced it as e to the x. You can have any number you want there, though, besides 0 and 1. Keep it a positive number. Otherwise, then there's transformations, like if it's a -3 to the x power, then there'd be a reflection. Number 5, what is the equation of the parent function below? I don't want you to get the equation of this graph. It's just what general shape is this graph. And this one is the general shape. The parent function looks like that. If there's transformations that happen to it, then you'll get the red graph. Or there are transformations that happen, then it'll get the red graph. But this is a square or cube root function. Or what is the equation? Y equals, cube root of x. Have to add that little 3 there. Number 6, what is the equation? It's the only coordinate that we're studying this year, only parent function that has a starting point. And you can see those two coordinates, they get transformed. But it is y equals, this is a square root. All right, now we have to get into graphing. So when we're graphing, the number 7, I'm actually looking at, I look at all the different transformations within the equation, or all the different parts. We have, it's an absolute value. So it's going to be a v. Within the absolute value, inside of the absolute value, we have a x plus 1. So with the x, think left and right. The plus 1 means left 1. Then we have the on the outside, the plus 3. That after the absolute value parent is written, the plus 3 means up 3. Now we just got to put all these together when it comes to the from the parent function. So the parent function, 0, 0, 1, 1, -1, -1. V-shaped. I'm going to start with left. If we're looking at this, start with the order of operations. So we're going to go left 1 first. And then I'm going to go up 3. So left 1 on all the points. And then I'm going to go up 3 on all the points. So 1, 2, 3. 1, 2, 3. 1, 2, 3. And draw the V. So that's your answer. All right, number 8. I'm going to do the exact same thing. I'm going to look at, this is a square root function. What other transformations do we see? We see a reflection. There's this 3 here, dilation. And we can talk about the +4. That means right. Nope. Left 4. Not even Friday yet. And lastly, let's go with pink. Up 5. So a lot of stuff is happening in this graph, so we'll get to it. So first, it's a square root function. So square root 0, 0, 1, 1 goes off to the right. So those are our key coordinates. 0, 0, 1, 1. First thing I want you to do is actually we're going to work on dilations. The dilation is 3, and I'm going to take the negative, I'm going to say it's -3. And what you do is you multiply the y values by the dilation. And that's actually going to incorporate the reflection in the negative. So it becomes y equals, the x values stay the same, 0, 1. The y values, though, change. It's going to be 0 times -3 is 0. 1 times -3 is -3. Let's plot those points. 0, 0, and 1, -3. So it's a much steeper graph now. So now we did the dilation and the reflection all at the same time. We know it's a square root, so check, check, check. We need to go move the points now left and up. Doesn't matter the order you move them in. So we'll go left, left 4, 1, 2, 3, 4, left 4, 1, 2, 3, 4, and then we got to go up. So up 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, and draw that same shape, and then that will be the answer. So that's the answer. That's what I need on the test. Write the equation of the following graphs. So looking at number 9, it's a rational function. First thing I want you to do is pick out nice coordinates. There's only 2 nice coordinates here. That's at 4, 2, and 2, 0. I say nice coordinates because they actually have, they're not decimals. They're integer coordinates. Their x and y values are integers. Next, let's look at the parent function, where would that be? Parent function from 4, 2 comes from 1, 1. All you do really need is to look at that portion of the graph, but you can look at -1, -1 also. So the 2 portions of the graph that you're looking at in total here, you have, what I would do is I would concentrate on these top 2, the black and the blue there, or the bottom 2. I would not look at both of them at the same time. If one transformation happens to one part of the graph, the other part automatically comes with it. So they're not separate. So you only have to really look at one part of the graph. And we're always going from the parent function. So the equation, what's happening here? Well, this blue line, the blue graph can actually, it can move, if it shifts over and up, it'll trace the black. So there's no reflection that happened, but looks like we're moving 1, 2, 3 to the right and 1 up. 3 right, 1 up. And it's a rational function. So now I would say it's a rational function. So y equals 1 over x. Right means you're incorporating that with the x underneath. And right is opposite of what you think, so it's -3. And then up means +1 after on the outside. And there's your equation. Number 10. So we're going to do the exact same thing. It's a cubic function. Do this in red. Cubic function. So I've got my key coordinates. General shape of the graph. Not exactly like what you see there. But the main point I want you to focus on is 0, 0. This is where the graph becomes very flat. Steep, very steep here on the bottom, flattens out, and then it goes steep again. Where it flattens out, that's the easiest point for me and most people to see the key coordinate. So the first thing you should know, well, it's a cubic function. It's real high. If you didn't notice that, look back at your notes from the first day. Then you see that this red graph cannot shift left, right, up, and down to cover up this black graph. It won't happen. So that means there has to be a reflection that has to happen. So we're going to say there's a reflection. And if you reflected these, the points would be here, here. So it'll look something like that, which is the shape of the black graph. It would slide right over now and it would be perfect. We're going to still look at 0, 0. And that point now has to go left 2 and down 1. If you did that, you take all the points, shift left 2 and down 1, you'll have those 3 points there, and the blue will go right over the top. So now we need to incorporate the cubic function, which is y equals x cubed, the reflection. So I'm going to put the reflection in there. Reflection is put the negative right after the equal sign. Then left 2, y equals negative. Left 2 is with the x, so I'm going to put it in parentheses x. Left is positive. Cube it, close the parentheses, cube. And then down 1, so we have down 1 is y equals negative x plus 2 cubed minus 1. And that's the down 1. There's your answer. All right, next is, for this graph, name the parent function and describe the transformations in words. All right, so this is parent function, absolute value. The transformations that happened, I see reflection. We see dilation. And we also see bright, 1.3, and up, 2.4. A lot of transformations that happen there, but that's all we have to do is name them. Next, so what transformations happen? First, we look and we see it's a quadratic. And quadratic, typically, the key coordinates that I had you remember are right there, 0, 0, 1, 1, and negative 1, 1. What's happening? It's not a U-shaped graph, well it is, but it's upside down. The only way you can do that is it's got reflected. So it's reflected. If it reflects, it's going to look something like this. Reflect on always the x-axis is what we're studying in here. Now it's the upside down U, so now we can shift the graph left. 1, 2. I'm looking at the vertex is mainly where my eyes focus right now. Left 2 and up 1, 2, 3. And there you go. And I think